Welcome to the Explainer. So today we're going to dig into something really cool, how artificial intelligence is tackling maybe the single biggest problem in clean energy.
All right, so let's get right into it. We all know renewable energy is like the key to a sustainable future. It's the promise of something better. But there's a problem, a big one. The vision itself is just so simple and powerful, right? A world running on the clean, limitless energy from things like the sun and the wind. It's the dream, and it's what's driving this huge global shift away from fossil fuels.
And boom, there it is. The fundamental challenge. These amazing natural sources, they're not always on. They're intermittent, they're unpredictable, and that variability creates this massive headache for our power grid, which is constantly trying to match a supply that's all over the place with a demand that's pretty constant.
And this isn't some what-if scenario. This is happening right now. Just look at this quote. It shows a huge, real-world consequence. In Britain, almost 10% of the wind power they could have used just got thrown away. Wasted. I mean, that's just a colossal amount of clean energy, not to mention a huge financial hit, all because the grid just wasn't smart enough to use it when it was being made. So how in the world do we fix that mismatch? Well, this is where artificial intelligence walks onto the stage. Think of it like giving our old, kind of dumb energy grid a brand new, super intelligent brain. And let's be clear, we're not talking about sci-fi robots here. When we say AI in this context, we're talking about incredibly sophisticated software that can chew through unbelievable amounts of data, weather forecasts, how much power people are using, you name it, to make our grid predictive, super responsive, and way, way more efficient.
And the difference here is, well, it's night and day. Just look at this table. The old ways, they're rated poor at adapting. The moment things get complicated, they just fall apart. But AI, it loves complexity. It delivers superior accuracy and high adaptability. We're not talking about a little upgrade here. This is a whole different ballgame. And this slide really nails the core shift in thinking. The old grid is reactive. A problem happens and then we react. The new AI-powered grid is predictive. It sees what's coming, changes in weather, spikes in demand, and it gets ready before it happens. That is an absolute game changer.
Okay, so let's make this real. Forget the whole grid for a second. Let's zoom way in on just a single wind turbine and see how AI can do something amazing, like predict when it's about to break.
Now, I know this flowchart looks a little intense, but the idea behind it is actually beautiful and simple. The AI creates what's called a digital twin, basically a perfect virtual model of a healthy turbine. Then it just watches the real turbines in the field, and the second one starts to act even a tiny bit differently. The AI knows something's wrong, way before it becomes a disaster.
So it really boils down to this three-step dance. First, you have all these little sensors collecting just a mountain of data. Then, the AI's job is to dig through all that noise and find the hidden whispers, the subtle patterns that scream trouble ahead. And finally, it sends an alert. But it doesn't just say, hey, there's a problem. It says, hey, that specific bearing is going to fail in about 3 weeks. But how does it know what to look for? Well, this analysis tells us exactly that. The AI has learned that the vibration level, making up more than a quarter of the decision, is the #1 clue that something's about to go wrong. You combine that with tiny changes in temperature, and you've got an incredibly powerful early warning system, one that sees things long before any human ever could. Okay, so that's one turbine. Pretty cool, right? But now, what happens when you take that exact same predictive brain and you apply it to thousands of turbines, millions of solar panels, and the entire energy grid? Well, the results are just staggering. So, first big impact, a 35% drop in unplanned downtime. Just think about what that means. The lights stay on more reliably, and we're not spending millions on last-minute emergency repairs. That's a huge win. And get this, we're seeing an 8.5% jump in energy output from the exact same equipment. We don't have to build anything new. AI is just making what we already have smarter, squeezing every last drop of clean energy out of it. It's like getting a free power-up for our entire renewable fleet.
And this number might be the most mind-blowing of all. Problems are spotted 77.4% faster. Let that sink in for a second. The average time it takes to find a problem plummets from over 18 hours down to just 4. That is the critical difference between a cheap, scheduled fix and a catastrophic grid-shaking failure. And this smart tech isn't just for the giant power plants. The very same logic is coming right into our homes. Pretty soon, you'll have an AI quietly managing the energy flow between your solar panels, your car, your home battery, automatically finding the cheapest, greenest power for you every single second of the day.
But with all this incredible new power comes a really profound sense of responsibility. As we start handing over the keys to our most critical infrastructure to these algorithms, we have to stop and ask some very, very important questions. And these aren't just little technical issues we can patch later. These are deep, fundamental questions. Who owns your energy data? How do we make sure the AI is fair and doesn't accidentally penalize certain neighborhoods? And, maybe most importantly, how do we protect this brand new, intelligent grid from brand new, intelligent cyber attacks? And you can bet the technology is not slowing down. We're already looking at the next steps, like using blockchain so you can securely sell extra solar power to your neighbor, and eventually even using quantum computers to solve energy problems that are literally impossible for us to solve today. The grid is only going to get smarter. So, at the end of the day, this is the big question we're left with. The tech to build a clean, smart, and hyper-efficient energy future, it's here, it's ready. So our challenge isn't really technical anymore, it's a human one. Can we build this future responsibly and make sure that it's fair, safe, and truly benefits everyone? Thanks for watching.